To solve is continue solving these problems. Let us do them quickly so that we can cover more interesting problems. Okay, so please interact with me, but let me just write it because we will be behind the schedule anyway. So now this problem, show that this line passes through this point. Everyone, what should I do?
We put the x and y coordinates into the
Thank you.
equation.
Thank you. Thank you very much. So I will do this. I'm asking, is this point here? Yeah. And then what I do, I would write 2 over 3. Instead of x, I put the x coordinate minus 3. Instead of y, I put minus 2. And ask myself, is this equality true or false? So it means that I have to calculate this 3 and this 3 are cancelled, so it becomes 2. And this minus 3 times minus 2 is positive 6 equals to 8. I need to ask this question, true or false? It's clearly true. So this means that A lies on the line. So as simple as that. Okay, now tell me about this question. Determine x and y intercepts of this line. These are standard problems. You shouldn't spend time in understanding. Of course, you need to understand it, but immediately you should be able to do it. So if I want to find x and y intercepts, what should I do? Someone else? Hello?
Solve for x or y.
So what do you mean solve for x?
You try to solve the equation as you isolate x and then...
No. That's so how this will give me x-intercept. This is good for y-intercept. I understand what you're saying. You are saying that if we write this equation in this form, then this one is the y-intercept. By the way, this is not the y-intercept. Do you remember? It would be 0 and m. Because when I talk about intercepts, I mean about points. So this will give me, even if this is working, of course it is working, it will give me the y-intercept. But what is the x-intercept then? I think now you are right. You said that I solve for y and for x. When I solve for y, I get my y-intercept. You are right. That is working. And then if you solve for x, this will give me the x-intercept. But I prefer to do it in a different way, and I want you to learn this method. If I want to find the y-intercept, I put x equal to 0 in the equation, and I don't need to reorganize, spend time on organizing it. So it becomes 4 times 0 minus 3 times y is equal to 8. Then I will solve this equation and find y. This is gone. So y becomes minus 8 over 3. Then I would say that y-intercept is this point. The point whose x-coordinate is 0 and its y-coordinate is this. So you see, I don't need to reorganize things. And then I put y equal to 0 if I want to find x-intercept. So then it becomes 4x minus 3 times 0 is equal to 8. Then it means that 4x is equal to 8, x is equal to 2. So this means that x-intercept is equal to 2 and 0. Is that understandable? But as you said, I didn't actually solve this problem in that way you mentioned, but I realize that yes, if you solve for y, you can find your y-intercept, and if you solve for x, you will get your x-intercept. But remember, x and y-intercepts are not single numbers, they are points, so you need to write them as points. Any questions?
Also, yeah, I have a question. Why did you actually say x is equal to 0 and then y is equal to 0?
Because so this means that here, if I have a y-intercept, so assume that this is your point, yes? You want to find the x-intercept. This point has 2 coordinates. One x-coordinate, which you don't know, but y-coordinate you know. What is that? It is 0, yes? Because it is lying on the x-axis. And you know that this point lies... Okay, let me do it a little bit more properly. So let me just do it for the x-intercept. So I would say that Generically, x-intercept is something like this. Okay, you want to find that. You say that this point, the x coordinate I don't know, but the y coordinate is 0. On the other hand, I see that this point lies on the line. It means that the coordinates of the point should satisfy the equation of the line. It means that instead of x, I put x, but instead of y, I put 0, and I find x. I did the same thing. I put x equal to 0, and I found y. Is that understandable?
Yeah. Thank you.
Yeah. So remember, of course, you need to understand that was a good question, but you need to remember that whenever you want to find y-intercept, you put x equal to 0, and when you want to find x-intercept, you put y equals to 0. But if someone asks you why this is correct, you should also be able to explain that. This is crucial if you want to be good in mathematics. Okay, so determine an equation for the line whose slope is 3/2 and passes through this point. Okay, I want to solve this problem in 2 different ways, and I insist you to learn this new method 1.4, which was introduced in this lesson. Okay, so if I want to solve this problem, I would say that, okay, one way, this is probably an old method that you know, you write that this is my equation for the line that I am looking for, and I am completely on the safe side. I am not losing anything. Do you remember it? This equation is not capable of giving you vertical lines, but there is no worries in this problem because the problem itself is telling you that this slope is 3/2. So definitely this line that I am looking for is not a vertical line, so it's on the safe side. I'm on the safe side if I say that my equation has this form. But I want you to understand, I'm reviewing what I was talking before. Okay, so one method is this, and I would say that you are telling me directly in the problem that k is equal to 3/2, so I don't have any problem with that. I replace k with 3/2 that you gave me, but I am still not done because still m is missing. What I have to do, I need to use this extra piece of information that you have provided for me. My line is supposed to pass through this point. So this means that this is a point on the line. So it means that its coordinates should satisfy the equation of the line. It means that if I replace y with the y value, replace x with the x value, this equality should be a true equality. So then it means that instead of y I put -1, instead of 3/2, 3/2, instead of x I put 2, and then I have m. Yes? And then this becomes -1, 3/2 times 2 is simply 3, m, I move 3 to the left, it becomes -4, so m is -4. If you stop here, it's wrong, because the question asks you about determine an equation. So what you need to provide as an answer is not m, is not k, is the equation that you are looking for. The equation is 3/2 x minus 4. So this is what you have to provide for the answer. Okay, and now the other method you need to remember, of course this is also you are remembering this formula. By the way, in American and English books, let me just mention it, they write it like this: y is equal to mx plus h. And there is something a little bit unfortunate. What Swedish books use for y-intercept is used as a slope in American and English books. And then the y-intercept is denoted by this. So if you are reading an English book, probably don't get confused. So this m is the slope for their notation. Okay, so
Question.
yes?
Does the M and H stand for things in?
No, I don't know. I cannot find any word for m and h. H might be the height something, but m I don't know. Yeah.
Okay.
No problem. So now let us go to the second method. The second method, you need to remember this formula: y minus y node is equal to the k value x minus x node. Yes, this is also possible. But you need to write what is y node. Y node is the y coordinate of your point, which is -1. K value is given directly, and then you have x minus x naught. X naught is the x coordinate of the point. So in principle you are done, but you need to, for here, when you put k here, it's still not done because you need to find m. But here you are done. There is nothing more you need to find, but of course you have to reorganize it a little bit. So I would start simplification. So it becomes y plus 1, and I multiply 3 over 2 inside, so it becomes 3 over 2x. But when I multiply 3 over 2 by 2, 2 and 2 cancels, 3 is left, so it becomes -3. And then I move 1 to the right, it becomes -1. So it becomes 3 over 2x minus 4. And this is now directly your answer. Yeah, I want you little by little at least know about this formula and this method. These are standard problems. They are not hard problems, but it means that if a question is like this, you don't need to think at all. You have to immediately start solving the problem. But more complicated problems are those problems that you need to think about. You use these kind of knowledge and then be a little bit creative to solve harder problems. Okay, no questions?
No.
Let's go to the next one. For example, determine an equation for the line whose slope is -3 and intersects the x-axis at the point whose x-coordinate is -4. So you see, this is essentially the same problem, but it is just making it looks like a little bit more complicated. Yes, so the slope is again given you directly. So if you don't mind, let me now use 1-point method so that you also learn that, because you already know the other method. Okay, so if I want to give an equation for a line, this is my formula. I need to know x node, I need to know y node, and I need to know k. I don't have any problem with k. K is given directly to me, and that's -3, so k is equal to -3. But this is my duty to find a point on my line. And it, by the way, a line includes infinitely many points. You just need one of them. It doesn't matter which one. Any one that you are convinced it is on your line, you take it, write its x coordinate here and its y coordinate here. Now, how do you interpret this sentence? Whose slope is -3 and intersects the x-axis at the point whose x coordinate is -4. It's making it very long, but what is the point? What is?
Does that mean
yes?
-4? Well, -4 is 0 is the coordinate.
Yeah, exactly. So instead of giving this point directly, they are writing it in words. Yeah, just the same problem. So what you need to write, you need to write y minus 0, because y node is the y coordinate, and k is equal to -3 and x minus -4. So this becomes y, and then this becomes x plus 4, and let me multiply -3 inside, so it becomes -3x minus 12. So that would be the answer to this problem. Okay, so it's very simple. But now, these 3 problems, I intentionally made them 3 problems. But if you see, they are identical, except that I am playing with these numbers. Determine an equation for the line that passes through 2 points. The same question again, the same question again. I have some intention behind that, the reason that I have repeated it 3 times. Okay, can you think a little bit about this and answer me?
Think about what?
Yeah, this problem for these 2 points. I want you to determine an equation for the line that passes through 2 points. Because usually when I ask you about 2 points, when I ask you about writing an equation for a line, you need 2 pieces of information. You need the slope, you need one single point. One single point is enough. Here, I am not giving you the slope, but instead I am giving you an extra point. But you need to think in this way. You need 1 point, good, you have even 2 points. You need to find a slope, if there is a slope here. And then reduce this problem to the old problem that you know and try to solve the problem. But these two are simple versions. You really don't need to do anything extra if you just a little bit be more observant and look at the numbers that appear.
Isn't the line there a vertical line?
Vertical line, okay, yeah, that's correct.
The
But
first one.
it's,
And then the other one a horizontal line.
so exactly. So what do you write for this equation then? Because you need to write an answer. What is an equation?
I don't know.
No, you know, yeah, because you know that this is a vertical line, but that vertical line passes through which point?
-3.
-3, yes. So then the equation that you need to answer is -3. So let me make it a little bit bigger. So here, what was the point? So let me make it bigger here so that we can also see the points. Okay. So this picture is not into scale, so forget about the scaling. But let me try to draw something here for you. So here you have these two lines, x-axis and the y-axis, and then this point is -3 and 1. So assume that this is -3, -1, -2, -3, and then 1. So this is your point. Agree? This is my point A. Another point, be careful here, the x coordinate is the same, the y coordinate is 5. So this was 1, 2, 3, 4, and 5. But the x coordinate is again -3, so it would be exactly on top of A. So this is B. Now I am looking for a line that passes through these 2 points, yes? It's clear that this line should be this line.
Is it x equals -3?
Exactly. So now you see that this is x equals to -3. So be careful about this point. So this is -3, but this you cannot just draw this picture. What you need to provide for me as an answer is an equation. So you need to write x equals to -3. If you want to motivate that, either you can draw a picture or you can say that these 2 points lie on top of each other, so this would be a vertical line. So this is a very simple one, just by realizing that these two have the same x coordinates. Okay? Now you see why I am giving you 3 equations. Three problems with the same topic, yes? Now here, can you tell me what is the answer immediately?
Is it y equals to -2?
It's y equals to -2 because these 2 points, they have the same y values. If you want to, you can just again do the same thing. So here, what I do, for example, again, let me take this, is not to scale. Okay, so I need y coordinates, so let me draw it here. So this is the x-axis and that's the y-axis. And then where is A? A is 1 and -2. So assume that this is 1 and this is -2. So this is my A. Yes, this is my A. Where is my B? 3 and -2. So this is 2, this is 3, and this is -2. 1, 3, -2, and this is my point. And now you see that I am now interested in, let me clean this and write it a little bit lower. This is -2, and then I want to draw the graph of draw the line that passes through these 2 points. I hope that it is clear for everyone that this is y equals to -2. So what you need to answer is y equals to -2. Yes? Okay, now these are special cases, but then how do you tell me what is your opinion about to solve the next one? The next one is essentially the same. You see, word by word I have copied and pasted. The only problem is that I have changed the numbers. So the x coordinates are not the same, the y coordinates are not the same. So I cannot answer this question as fast as I did for these 2 questions. But do you have any opinion what to do now?
So can't we use delta y over delta x?
Okay, thank you. So you shouldn't lose the strategy. You shouldn't get confused because you know the standard way of answering an equation for a line is to have one point and the slope. For one point, you don't have any problem. If you want, you can choose this, or if you want, you can choose that. But for the slope, you need to think, can I find the slope of this line? If you think in this way, then you immediately realize, okay, there is a formula for k. It's very famous, so you need to know it's delta y, as Rocco mentioned, over delta x. And then delta y is y1 minus y2. It doesn't matter if you write y2 minus y1 because who knows which one is the first one, which one is the second one. But what is important, which order you choose here, you have to respect for the denominator as well. If you write y1 minus y2, so you have to also write x1 minus x2. If you write the other way around, the other way around. So then it means that...
I'm confused.
Yes?
Why is delta y1 or y2?
What do you mean? So delta. So this was the formula. So
how do you change from delta y to y1?
no, what is delta y? So let me forget about that. So let me try to show you something from previous sessions. Yes. So here. So do you remember this was the formula for k? Okay, and then because there is a symbol called delta. Delta is the Greek letter delta. This is the uppercase letter Greek, and this is the lowercase letter. But in mathematics, when we use delta and we put a variable in front of us, in front of this delta, it means that we are interested in the change that happens for y value. This is the meaning of delta y. Is that understandable? So you see here, I am interested in a change between two values of y. So instead of writing it in this way, people write it shortly as delta y, the change in y. And then here you see that I am interested in the change between two x values. Of course, I can write it in this way, or I can simply show it with delta x. Is that understandable?
Yeah, but is this delta connected to b squared minus 4ac?
No, okay, so thank you for asking me this question. This is an unfortunate thing. That delta, I don't know, now I understand what you say. This delta b squared minus 4ac is totally unrelated to this delta that we are using here.
But they're both called delta.
That's an unfortunate thing, yes, you are right.
Okay.
They are called both delta.
Confused.
But the point is that in that delta, you don't have anything in front. That is just delta equals to square root of b squared minus 4ac. Yes?
Yeah.
So yes, probably, I don't know, Greek invented this or whatever, so they use this one. Because in mathematics, this is called discriminant, and might be it's a better way to show it with d. And by the way, I think this in Greek, this is pronounced a d, I think. I don't know. So it might be that's the reason, okay? But you see, at least there is no matter of confusion, because in that delta, there is nothing in front. So this means just delta,
Okay.
yeah? Okay, but thank you for asking this question, because sometimes these things are so trivial for me, I even don't understand, I have to explain. Okay. So here, if you don't like, just totally forget about this. The formula for k is this one, yes? And this is up to you which one you want to call x1, which one you call x2. So let me, for example, just do it alphabetically, yes? Let me call this one x1, this one y1. There is no difference. You can check it yourself. And call this one x2 and this one y2. Okay? So then let me solve the problem. I replaced the numbers. Instead of y1, I decided to put 3. So minus, what is y2 is minus 5. So be careful, be patient not to mess up these negative signs. Divided by x1, which is minus 2, minus x2, which is minus 3. And now this becomes 3 plus 5, and then divided by minus 2 plus 3. So the numerator becomes 8, the denominator becomes 1, then the answer becomes 8. Okay? And now what you do, now you have your k value. So this means that the problem is reduced to this old problem that you know how to solve. So what can I do? I can write the formula. Intentionally I am using this so that you also get used to this formula. So it is k times x minus x naught. Okay? Again, don't get confused. Now can you tell me, what should I put instead of k? Everyone, what's the answer?
8.
It's 8. But hopefully you are not confused. What should I replace for x naught? Can you tell me?
Maybe you put one of the numbers.
Well, yes, that's correct. Which one you mean? Just name it.
Maybe x1.
Maybe x1. So this is what I was. I hope that you are not confused. You are not saying, Babak, you are calling it x1, and now you are telling me instead of x naught, again put this one. If you understand what's going on, this is not a question, actually. You understand what's going on. X naught and y naught are the coordinates of one of the points that I know is on my line. Okay? So you need to make up your mind. Either to work with A until the end of the problem, or work with B until the end of the problem. The final answers would be the same. Pardon?
Because the points both are on the same line, it doesn't really matter.
Doesn't matter, exactly. So let us, of course I will check it. So I want to show there is no difference. Let us use A. Okay, so let us see what happens if I use A. Then it becomes y minus y naught, which is 3 in this case. K value is 8, and x naught in this case is minus 2. Let me simplify it. And let me multiply it. And then let me move it to the right. This is the answer that I get. This is my answer to this problem. Okay, now let me solve the problem. Let us using B this time. Okay, so let us do that one. Let us see how this goes. It becomes y minus, this time instead of y naught I put this, instead of x naught I put this. So it becomes y minus minus 5, k is the same 8, and then x minus minus 3. So you see the intermediate step is different from this intermediate step, but you need to be patient to do it until the end. So it becomes y plus 5 is equal to 8 times x plus 3. I multiply this, 8x plus 24, I move it to the right hand side. 24 minus 5 is again 19. So you see, there is no inconsistency going on. That would be a catastrophe for mathematics. If you solve with this one, it becomes an equation. If you solve it with this one, it becomes totally different equation. But so you see, it doesn't matter. So this is also a standard problem. So now you know that if you want to determine an equation for the line that passes through 2 points, how to do. There are 2 exceptions that you can do it immediately, but you need to visualize it. Okay? And there is a situation that you need to really solve it. It is not possible to immediately answer that. Any questions?
What level is example 11?
I would say C level.
Okay.
Yeah. Is that understandable now for everyone?
Yeah.
Okay, so let me just try to test this GeoGebra and see that what. By the way, let me ask you, how do you evaluate this question? Determine an equation for the line that passes through this point. Full stop. What do you say to me?
Hello.
Yes?
Maybe you say hello.
No? Except for hello.
Well, you can use the standard form too.
No. Be careful.
No,
These
you're missing one piece of information.
Yes, so I am not allowed to say the line passing through one point full stop. Is there the line passing through one point? There are infinitely many points. So I cannot ask. So I want you to have it, because this is algebra. This is algebra for geometry. So I want you to have a geometric visualization, the imagination behind your head all the time. So this is not meaningful. I am not allowed to ask that. I can ask, for example, I can ask you something. I can ask, write equations for all the lines that passes through this point. If I ask that question, then you can say that, okay, y minus 3, you haven't given me k, so I just put k, and then it becomes x minus minus 2, x plus 2, and then what I do, I simplify it. It becomes kx plus 2, and then plus 3. And then it becomes y equals to kx plus 5. This is not the equation, because still k is missing, but I am telling you all possible equations that for the lines passing through this. This is not one equation. This is infinitely many equations, each for one possible choice of k. Okay? So be careful. So you need to be careful about these things. Okay, let me try to see this with GeoGebra. So I will do these things. I will highlight these points on GeoGebra, and then I will try to draw this graph, and you will see, hopefully, if you have done it correctly, this will pass through these points. Okay, let us check that. So here we go, and let me just type that y equals to 8x. Let me first put let me put the points first. It's more exciting. Yes, 1 minus 2 and 3. This is one of my points. I don't know why this is drawing the graph. This is vector. Oh, okay. So in GeoGebra might be when you are using the lowercase letter, it is automatically. So let me write a is equal to minus 2 and 3. Oh, that's point. So you see it's highlighted here with this black dot. And then I go to the next step. Let me put b is equal to, what was the point? It's minus 3 and minus 5. That was the point. Yes. So where is it? It cannot be seen here. Okay, so this point is here. That point is there. Okay. And now let me make it a little bit smaller so that you can see. These are the points. So let me show the label. So show label here, that's point A. Show label here, that's point B. So I know probably this will go this way. So let me put B here and A there. Okay, now let me type the equation that we found. I found for you y is equal to 8x plus 19. Okay, so that's it. So you see, if I zoom in, you see that the line that I just typed the line in, but it has the property that contains both of those points. Is that understandable?
Yes.
Okay, good. So let us go back to see what do we have now. This is a more interesting problem now. I want you to read it, then tell me what to do. What is your idea? Show that these 3 points lie on the same straight line. There are 3 points given with 3 given coordinates. You are supposed to show that these 3 points lie on the same line. Of course, one way to demonstrate it is to just highlight these points using GeoGebra. And then even with GeoGebra, is it easy to see? Might be, because if the deviations, for example, if the points are like this, might be you see. But if the points are actually differing a little bit, so for example, it's a little bit above, it might be so small that you cannot see the deviation. Okay, so how do you do it even if you have GeoGebra?
So I don't know if this is the most effective way, but you could do just choose two of these points and then do delta y and delta x, so
Yes.
you get an equation, and then you can for the last one you can just put in the numbers. And
Exactly,
you can prove
exactly,
that it's
exactly. Thank you very much. So that's probably a very good strategy. So even if you want to do it with GeoGebra, so let's probably do something here. So what we can do with GeoGebra. So let me go to GeoGebra here. Let me get rid of all these things. So I am just typing the numbers. You cannot see the numbers, but you need to trust me on that. So A is equal to 5 and 7. So let me highlight these points. And then there is another point B is here. I gave it to be 4 and 3. Yes, so I forgot to put these pair of brackets around that. And that is my point B. And this, my point C, is given to be 6 and 11. Okay? Might be you have the feeling that yes, it seems that these points are on the same straight line, but might be, who knows, might be the deviation is so small that you cannot detect it with your eyes. So how we can do that? For example, I will take this option, line, passing through 2 points. And I take this one and I just click on these 2 points. So let me, for example, let me give the labels here so that you can see. This is point C, this is point A, and this is point B. Okay, so what I want to do, so let me move this a little bit around, and then I will use this option. This gives me the line that passes through 2 points. If this is correct, when I click on A and B, you will see the line will also passes through C. Let us check. This B and then this C. You see, when I just clicked on A, automatically it passes through C. So this demonstrates that these 3 points are lying on the same line. Okay, but analytically, by the way, this is not 100%. Of course, you might say that, okay, the chances are very low. But if the deviation from straight line is so small that we cannot detect it with our eyes, then it might be wrong. So we might fall into the wrong conclusion. There is a very, very nice conundrum or riddle. I will try to find it for you next time. And then this you will appreciate that what I am saying. You might say that, okay, it's clear that they are on the same lines, I can see them, but I want you to understand that this is not the case. I will try find it out and then share it with you next time. Okay, so let us go and follow a strategy that Rocco mentioned is completely right. Because what I do, I would say that I will write an equation for the line passing through these points A and B. I pretend that this is not there. And then when I found the equation of the line that passes through point A and B, I want to show that this line will continue and passes through C. It means that then I can show that this C lies on the line. How? By putting these numbers in the equation that I found and show that this becomes a true equality. So that is a strategy. Okay? So let us just do it quickly. It doesn't matter, by the way, it doesn't matter if you want to work with these two, and check the other one, it doesn't matter. Let us do it alphabetically. Let us start with A and B. Okay, then based on the experience on the previous problem, one of them I call x1 and y1, the other one, that's arbitrary, x2 and y2, then we write delta. So let us ignore delta here if it's confusing. So then I would write y1 minus y2 divided by x2 minus x1. So what is y2 is 3, what is y1 is 7, what is x2 is 4, what is x1 is 5. So the numerator becomes minus 4, the denominator becomes minus 1. And then if I simplify that, it's 4. So my k value, the slope is 4. Yes? Okay, and then I write the formula y minus y node is equal to kx minus x node. So I decide to work with A. You realize there is no difference. So it becomes y minus 7 is equal to 4x minus 5. And then I simplify that. It becomes 4x minus 20. And then I move it to the right hand side. So it becomes 4x minus 13. So this is, if you want to write something, line that passes through A and B. But then you don't need to find an equation for the line that passes through this one and that one. That idea might also work, but why we should make trouble for ourselves? We want to show that this line also passes through this point. Again, you know what to do. You need to replace x and y with these coordinates and see if it is true or false. So instead of y here, I put 11. Instead of x, I put 6. Then what happens? 11 question mark is it equal to 4 times 6 minus 13? Let us simplify. 11 is equal 24 minus 13 question mark. 11 is equal to 11. True. So therefore C lies on the same line. Is that understandable?
Can you explain it once more?
So what I did, I just wrote the equation for the line passing through 2 points. Yes, this is exactly the problem here. 2 points, and then I did it. So I found an equation. Here, the equation that I get is this one. Now the point is that, is the third one is also on the same line? Then this is a problem that you yourself, I think, if I remember, answered it here. When I ask you, how should I know that a point is on a line, you told me that you need to replace and see if it's true or false. So I am combining 2 problems into 1 problem. That's always the nature of mathematics. So you need to have building blocks in your head. So your brain should be organized. So building blocks, I don't know, the important problems, they are simple problems, by the way, but you need to have them in your brain in a very good way, and you need to understand them perfectly. So then harder problems are a combination of simple problems. Okay? So I found the equation of these 2 lines, and then I ask myself, is this point also lies on the same line? If the answer is yes, by checking this, then of course these 3 points are lying on the same line. If the answer is no, it means that this is not lying on the line that passes through these 2 points. Is that clear now?
Yeah.
Okay, so now I realize, by the way, there are some nice features of GeoGebra. For example, if you go here, what's this one? Okay, see, there is a called a slope. For example, if you want to find the slope of any line, then you just click on 2 arbitrary points on it. For example, let us just choose this point. Okay, by the way, it did it. No, you don't need to choose 2 points. You just need to choose the line. So then it will give you that. So you see that they are mentioning the slope by 4, by m, not by k. So we go 1 unit to the right. You see that it goes 4 units upward. So this means that the slope is actually equal to 4. There are very nice features. I will try to use this more effectively when I am at home, at least. Okay. But the other problem might be considered to be a A-level problem. But again, it should be a matter of seconds for you to understand this problem. Here,
Do you mean that example 12 is A or example 13?
No, example 13 would be A level.
Okay.
Yes? So here, you see the structure of the problem is mainly the same. But here, I have given you 3 points. Here, the last point is not completely given. Yes? Because n is missing. But now I am telling you, consider the points, determine n such that these points lie on the same line. So, because this is not a fixed point, by changing the value of n, C changes its position. So I cannot say that, are these 3 points on the same line? How can I answer? This is not a specific point. By changing the value of n, the coordinates of this point is changing, so it means that this C starts moving around. I will demonstrate this. There are a lot of mathematics in that one as well. But let us finalize this problem. But you see, even though I consider this a A-level problem, it is very easy. Because what you say that again, I act as before. I will try to find an equation for the line passing through these 2 points. And then I demand this point to be on the same line. Let us just do it one by one. First of all, you have enough experience. So let me write x1, y1, x2, y2. Let me write k value is y1 minus y2, or the other way around, but you need to respect the denominator the same order. So this becomes 9 minus 5. The denominator is 4 minus 3, so it is 4 over 1, so it is 4. So the k value is 4. And then you use this 1 point formula, for example, or whatever you want to. Using the old method is also fine. So I am using A. I am using A for my solution. So it becomes 9, 4, x minus 4, and simplify that. So x, let me just do it in 2 steps. So it is 4x minus 16. I move 9 to the right hand side, so it becomes 4x minus 7. Yes? Okay, so this is, if someone asks you what is this, I would say the line that passes through A and B. B, okay? Now, I demand that this point lies on this line. What does it mean? It means its coordinates should satisfy the equation. So what does it mean? It means that when I replace y with the y value and replace x with the x value, it should be a true equality. So then it means that C lies on the line. This implies that instead of y I put 3n, instead of x I put n plus 1, and then minus 7. You see, I replaced y with 3n. I replaced x with n plus 1. Hopefully, if you remember, if you do it like that, it is wrong, because people will read 4 is multiplied, but what you mean is the whole expression. And then what is the name of this guy in mathematics? This is called an equation. So I solve this equation as we know before. So it becomes 4n plus 4 minus 7. So 3n, I move 4n to the left. On the right hand side, 4 minus 7 is what? Is minus 3. And then I have minus n is equal to minus 3. N becomes equal to 3. And this is my answer. So here, determine n, so that is the answer. So answer to this problem would be n equals to 3. Yes?
Couldn't you also say that n plus 1 equals 4?
No. N plus 1.
You just need to find n.
You are supposed to find n. The question is telling you determine n, and that's the story. N is this number. Is that clear? Okay, so you see that even though this is probably considered a level problem, it is nothing. Okay, but let me try to get some ideas out of it. First of all, let us do some demonstrations using that. So here, this point is not one point. Changing n will actually changes the position of this point. And there is a terminology in geometry, it's called locus, and the plural form is loci. So when I say find the loci of points C, it means that can you see what is the shape or that on which these points lie? Okay, So let me remember this form. C is n plus 1 and 3n. Let me go to GeoGebra, get rid of all these things first. If I type C equals to, what do you expect, GeoGebra? This cannot show you the point, yes? n plus 1, and then 3n. As soon as I press the enter, you shouldn't expect that GeoGebra locate the point for you, yes? Because how can GeoGebra do that? GeoGebra doesn't know what you want to give for n. But as soon as I locate, GeoGebra knows that might be it is a good idea to create a slider for you. And it created that. You see, it created a slider for you, and the default value is somewhere between -5 and 5. Let us keep it. And the reason that now you see this point is located here, because the default value n is equal to 1, you put n equal to 1 here, you get 2 and 3, this is why this point is highlighted. But then what happens, I can move this around, you see this point is moving. You see? By moving this slider, this point is moving. So it means that now you can also do some nice feature of GeoGebra, if I remember correctly. There should be some way that you can see the trace of this point when it actually show the trace. You see here, let me turn it on, and now, okay, let me turn it off for the time being. I want to go to the minimum value, so it is -5, it's here, and now let me go and trace that one. What do you think would be the shape here? That's a hard question. I want you to understand what's going on. So can you guess about the trajectory of this, say, particle when I start moving this around? Okay, so let me put this.
I don't understand the question.
The question is this. I'm doing this animation. Now what is this trajectory? Is it a circle or what is this?
It's diagonal. It's a line.
It's a line. So it seems a line. Yes. And now a hard question from my point of view, is there any way that you analytically can find the equation of this line? This is the trajectory of this particle. So you can assume this is a very nice problem, okay? So I would say, let me just do it once more. You see, if I go up and down, this particle is actually moving around. This trajectory is called the loci of the point C. It means that the positions, locations of this of this particle through by moving this around. Okay? And then what does it mean? Now let us do some other demonstrations. So here, if you go back, here we had 2 points, 4 and 9, 3 and 5. Yes, let me highlight these 2 points on GeoGebra as well. So here, I don't know how can I get rid of this one now. So let me see if I can undo it. Okay, good. So it is undone yet. So here now the points was here in this problem was 4 and 9. Yes, this is 1 point. The other point was b equals to 3 and 5.
Babak,
Yes.
if n is 3,
Yes.
then that would mean that a is the a coordinate is when n is 3.
No, if n is 1, if n is 3, this becomes
Yeah. So it's 3 plus 1, that's 4.
4, yes.
3 times 3 is 9.
Yes.
So it's 4,
Yes.
4, 9.
Yes.
Yeah.
So then what's the question?
I just saw that.
Yeah, exactly, that's the meaning. Here the default.
It's more of an observation.
Yeah, here that's just, this is the default value here, n is -5, this is why they put -5 here, -5 plus 1 is -4, 3 times -5 is -15, this is why you see this is highlighted here, -4 and -15. But let me try to label them. So this is an extremely important problem. You can also, you start learning mathematics by doing these things. Okay, so here this is the point. Let me use this feature of GeoGebra to write the point that passes through here. Okay, you see, by the way, let me just highlight this point, show the label. This is your point C. Oops, this is my mistake, sorry. Let me undo it. Okay, so you see this is your point C. Does this point lies on this line? No,
No.
it's not there. But we found for which value does it lie? We calculated
3.
n equals to 3. Okay, so let us see what happens if I just move it by hand. I am changing the value for C, you see. It's tracing, and then when it comes to 3, it should lie on the line. Let us confirm it using Geogebra. It's not there yet. Oops, 3. Now it is here. It's on the line. So you see what we saw. Pardon?
What I said before was exactly this, that
Yeah.
it only lies on the line when n is 3 and then it has the same values as a.
Okay, but that is a coincidence.
Yeah.
Because
I just saw it.
yeah, that was very nice observation, but that was a coincidence. You are right. This happens when C lies on A. But for example, if A was somewhere else, was here from the beginning, then you get another one. This is another very, I didn't realize that when I was designing. I was careless for this. But anyway, you see that at least our calculation is completely correct. Because when I choose n equal to 3, then this point exactly lies on the line and it becomes exactly the point A. Okay? So, but one important question is that if I want to get rid of this line, let me get, by the way, this is the equation of the line. It's y equals to, if I move 4x to the right, it becomes 4x minus 7, and you look here, 4x minus 7. So you see that I was able to get it using Geogebra. I just click on these points, Geogebra did it for me, so it also finds the equation. Okay. Now, the point is that if I get rid of this point, and then let me just go back here, and then let me get rid of these points, and just concentrate on the point C. So I don't know why there are two C's. I don't know. Okay, one of them is gone. So here, what my point is that if I ask Geogebra to show the trace, which I have already done, and animate this, here you get something like this. This would be the trajectory of your particle, and if we can trust our eyes, this trajectory is just a straight line. For example, to show that this is not always the case, let me change this n here. I am just working here, you see. Instead of n, let me write n to power 2. Okay? And then let us play this game again. Let me just this one, and then let us see what happens here. You see, this will behave a little bit strange. Now I will go here to see that this is not always guaranteed that this should be a straight line. So now let me show the trace and do the animation. What is this shape? Can you see at least? What is the closest shape that you know its name?
Parabola.
Parabola, yes. But it's parabola.
Screw you, Rocco.
Oh, yeah, so it is parabola, but in the other direction that we don't get. Of course, this is also parabola, but how we should be able to prove that this trajectory is parabola, this is a different topic. It's harder for you. But when it is when this is 1, this should be easy for you to prove that the trajectory or the loci, this is called the loci of this point C, the trajectory of this moving part C. Okay, so this is let us stop this animation. So even it might be a little bit complicated. Let us just if I make it 3 and then I can make it n, let us see if it works. I'm also interested myself playing some games, you know. And then let me make it to power 2, and let me just do that, and let us check this one again. Okay. Oops, that's a very strange behavior now. It works. Okay, so if you know mathematics, you can predict everything before seeing the demonstration, and that is quite fun. So you see the particle is moving like that now. Okay.
I would just like to say that that is an interesting curve.
Yeah, that's a very interesting curve. Yeah, but you can also find the name for that curve. I think there is a name for this curve. So one of them is degree 3, one of them is degree 2. Okay, at least you can see these features of the GeoGebra. You will learn a lot. So, but my open question for you is this. Let me not change anything. The question in the problem was n plus 1. N plus 1. And then you had it 3n. Yes? My open question for you is this. Can you, before doing some demonstrations using GeoGebra, can you find the equation? Because you saw that in this case the trajectory is a straight line. I ask you to think about this problem. Find an equation for that straight line. The trajectory of this point. Okay? Now I stop recording.